I'll give you a brief introduction to Lab Chapter 4. Recall that once you open up Maple, you'll click on the cloud and log in under the cloud. The lab should appear in the cloud. When you double click, it'll open into Maple. The first problem, we want to do an animation on the family of curves x to the fourth plus c times x squared. Notice that when you do such an animation, you have to have the times key. We'll begin by just copying and working with the right side. I'll press enter and right click on that. Go to plots and plot builder. When we get to this page, we select animation up at the top. It's on plot, you would switch to animation. Put in the values that you would like for C. Here, -10 to 10 should work fine. It shows x values of -10 to 10. We also want to take charge of the y values. So if we click on options, we should tell it that we want -15 to 15 as y values, or something similar. Click on plot. Click on the graphic that's created, and notice in the play bar we can press the play button. We see the animation. We want to think with the slide bar what values of C seem to be transitional. Seems as if for positive values and for 0 it's U-shaped, and then for negative values it's W-shaped. So for negative constants we would have two mins and a max, and if the constant is positive or 0 we just have one critical point, the min. You would click on text and explain what we just saw. We'd also want to show that with some calculus. So if we copy and paste that down below, we should be able to paste it from before. We can right click on it and find the first derivative, differentiate with respect to x. Of course we could set it equal to 0 and solve, but you can also right click and solve. It assumes it's equal to 0. Solve for x. And what does this tell us? Well, it gives us the three x values for the critical points. Notice that these two have -2c underneath the radical. So if c would be a negative value, that radical would exist. If not, it would be imaginary. So it's true that c needs to be negative in order for there to be for it to have three critical points. So the transitional value appears to be at 0. We would want to probably do the second derivative as well. I'll copy and paste the first. And if we get the second derivative, differentiate with respect to x, solve that one also for x. In a similar fashion, we see that we have square roots that the only way they could exist is if c would be negative. So if c is negative, you do have 2 points of inflection. We can see that on the picture, that when c is negative, we have a W shape. So there'd be a point of inflection around here, approximately here. It goes from concave up to concave down and concave back up. So that should make sense. And we've then explained with text what we've shown with mathematics as well. You would want to do the exact same for the next problem. You should probably press pause and continue to complete the lab question number 2, and then come back and I'll walk you through number 3. I would pause at this point. Number 3 obviously is an ugly function, not a derivative you would want to do by hand. We do want to get f prime and f double prime. We want to graph all three on separate grids. So I'll copy and paste this first. And let's go get the graph and see what it looks like. If I go plot 2D plot, it picks a window that's okay, but it almost looks like a hyperbola, and it's doing actually something different from -1 to 1. So it might be better to change those axes. We can right click, go axes, properties, and we don't need it to be this wide. we could go from -5 to 5, and maybe vertically it'll distort it a little bit, but if we go from -2 to 2, it should show us what's happening. There's a curve there. Now one of the errors it makes is that it's connecting. In fact, if we zoom in a little bit, we'll see that it's connecting where it's not supposed to. So we can fix that through Plot Builder instead. Go to Plots, Plot Builder, choose the X values you want. How about -5 to 5? Click on Options. Y values, we could keep it the same, -5 to 5. But we want to check mark Find Discontinuities and possibly even show removable. Plot more points if you want, but I think this should work fine. We click on Plot and we get the graph. Notice that it didn't connect anymore, but realize that at x being 0, it's actually undefined. So there's open circles right there, right there. Maple didn't want to give us the open circles, but it is undefined at 0. So this is the incorrect graph. We'll click on that and get rid of it. Hit delete. We want to also go get the first and second derivative, so I'll right click and differentiate with respect to x. There's the first derivative. We can clean that up a little bit if we go to simplify and say normalize. Puts it together, so it's a little simpler. We'll right click, differentiate with respect to x again. There's the second derivative. Obviously not something you would want to do by hand. We can again clean it up a little bit if we go to simplify and normalize. Puts it together. We also would like to plot each of those. Getting an appropriate window still may be a little tricky, but if we go to Plots, 2D Plot, it picks a bit of a tall, out of scale choice for the vertical. We can edit that, Axes, Properties, and maybe vertically choose something a little bit better. How about -2 to 5, and apply. You can see that the graph is positive, and it looks like it's 0 at 0. At the same time, you can see that it would be undefined at 0. So the graph is positive. First derivative is positive always, except at 0. That should tell us that f is increasing throughout, except at 0. I won't write it, but you would want to click and write that in text. Let's go graph the second derivative. Again, if we do a 2D plot, window is not fabulous, but it's okay. We could also click on this and zoom in on the interesting part of it. And the rubber band zoom tells us that the second derivative is switching from positive to negative to positive to negative. So these two spots right here are points of inflection. And once again, at 0, technically it's really undefined. So f would be concave up, f is concave down, f is concave up, f is concave down. Now, to find those points of inflection, if I right-click on this, I can solve it. But you want to numerically solve to get a solution. It's this spot, -0.416. By symmetry, the other one is +0.416. So those are the points of inflection, and you should put together the intervals then. -infinity up to -0.416. F is concave up. Then it switches to concave down, up to 0. And then after 0, it's concave up again. And then after 0.41, +0.416, it's concave down again. I should also show that if you solve the first derivative, again, if we numerically solve it, it doesn't give us an answer. In fact, if I solve and just do a regular solve for the variable x, it gives us an empty set. What that tells us is that this function does not have a max or a min. And so our graph down here, our graph down here does not have a max or a min. It may look like there ought to be, but recall that at 0 it's undefined. And so we aren't able to find those max and min points.